Now what we are going to do, we need to have some input for this and we need to have some targets. So let's create the inputs and targets here. INP equals we can pass all the inputs for our network one by one using the loop, or we can pass all the inputs and the corresponding outputs at one chunk, because this is a mm, batch dimension. It will take in inputs one by one and it will also take inputs as a chunk. So we at this in this case I'm going to provide all the inputs at once. So let's create a block, and this will be our batch dimension, and inside that batch dimension we are going to provide some inputs. I'm going to provide with 4 inputs. So 1 2 3 4, the last one is not required, and inside that input dimension we are going to put the values. So 1 1, I'm going to put 1 0. These are the inputs that I created. 1 will be 0, 0. So these are all the binary combinations of a 2-bit register, or whatever you want to call it. Out equals, and if we want to make it a XOR gate, let's say, so the output will be 0 if the inputs are same. So in this case inputs are same, so it will be 0. Again, this is not same, it will be 1, make it 1. 0 0 is same, so it will be 0. So these are the outputs. I guess there should be one refactor. Okay, so we have our input and we have our output. Let's train it. What we can do is session dot run, and we have our inside we want to evaluate the error. What is the error, how much error it has. We want to run the optimizer to optimize the value, and we have to give the feed dictionary for the input and the target. So the feed dictionary, the input is INP, target is OUT. We have our session. Now one thing is, it will run the input and it will train, it will place the output. As you know, the optimizer has a learning rate, and it will only modify the network in proportion with the learning rate. If the learning rate is very high, it will modify the network very rapidly. If the learning rate is very low, it will modify the network very slowly. So if the default learning rate is 0.001, so the network will be very slow to learn, but it will be steady. So the network will run the entire optimization for 1 2 3 and 4 times. But in our case, with this learning rate, that won't be enough for the network to get to the optimal level that we need for our testing. Means it won't be as accurate as the as accurate as we need. So what we will do, we will put it in a loop so that it keeps repeating the inputs and for some time, so that we can get more accuracy. So for that we will select one variable called epics, and we will set it, let's say 4000 times. and we will for why it is not coming. Okay, for I, okay, not required. For I in range epoc apex, for I in range, why it is in, and now okay, so now it will keep repeating the same inputs until unless it gets till 4000 times, and we will get some better results. Here the session.run will return the value of the cost and value of the optimizer. The value optimizer doesn't return anything, so we don't care the value of the optimizer, but we care the value of the error each and every iteration loop. So we don't care of the value optimizer, so we are putting underscore there to make it say that we don't care. And for the second, we have the error values. So we have the error values, we can print it. What is the error in that iteration? Let's run it. Okay, let's save it and see if there is any error. Let's run it. I hope there is no error. Okay, so this is 1000, 4000, 2000, 3000 and 4000. So the error is almost 0.24%. That is very high. And initially the error was from 3. It is not going much down. Initially the error was almost 1.4149, then it went down, it is going down, it is going down, and it is less than 1, and it is like this. After 0.24 it didn't went down that much. Yeah, it's almost saturated. After 0.34 almost saturated. So we want to test this value using our custom inputs. So after the training is done, what we can do is we can put a while loop here. While true, let's make it an infinite loop, and inp equals input. We want to input some value from the terminal. Let's say type first input, input 1, input. Okay, let's create a inp.
It's 11 o'clock.
Equals 0, 0, and now we will put this will be 0, the first input, this will be the second input. So we have the first input and second input, second, second input, and it will print us the output. In this case we don't need the target to print the output. We don't need the optimizer because we are not training it. We only need the output. So we are going to calculate the output, and the feed dict only we need is the input. So let's print the output here, save it, and let's run it. Okay, I found the problem is this should be for the first input, this is the second input. We should select the second index of that input. Now let's test it. Hmm, Otherwise it was really weird. We have our first input 1 and 1. Input is 1 1, the output is 0.03, which is less than half. And let's put it 0. Second input is 1 and it is more than half. Let's put it 1. Second input 0, it is also more than half. Let's put both of them as 0, it's less than half. So if we put a threshold in zero point 0.5, all the things above which should be 1 is above the threshold, and all the things that should be 0 is below zero point 0.5. So it's almost it's not accurate, but that is how neural network gives you output. It won't give you exact output value, that will be an overfitting, but it will give you one clear separation between the outputs.